Okay, so this time I've done it with an analytic approach here. In order to do this, first I realized that in order to make the ball A bounce off both blue walls, I needed to reflect it over both blue walls. So I've reflected ball B over the wall down here to C, and then C reflecting over the other blue wall gets to D. Then I've drawn a line connecting A to D, and I found the equation of that line by using those 2 points and finding the slope and then finding the equation of that line. Then I found out where the intersection of this line, line AD, intersects the side of the pool table here, and so that it intersects where x equals 5, so I plugged in 5 and I got 2. After I had this point where it intersects, then I connected that point to the first reflection, C, creating this line here, and I found the equation of that line using those 2 points, and I plugged in. Then I plugged in, and I plugged in y to be 0 here to find the intersection of the second one. So that lets me know that, so now I have the solution that the person who is aiming should aim at the side of the wall located at the point 5,2. The second time I did it, I used similar triangles instead. So first I drew the path of the ball, which was this green line, and then I took each green segment and made a triangle out of them. And then I had to realize that all 3 of those triangles were similar by angle. Not only do they share the angles, the angle of reflection here on each side is the same, but also each one of them is a 90-degree triangle, and then the third angle will be the same. Then I set up proportions with the sides, labeling the variables along the sides. The whole side was 10, and this was the piece that was x. So then what would be left would be 8 minus x. Then I have 3 triangles, 1, 2, and 3. I set up proportions with each of those triangles. And so then I cross-multiplied with those, and I came up with a couple equations and just substituted into them to solve. And so I got the same thing, that he should aim 2 feet up from the edge of the table right here. Great.